So this is a video to talk about how to find arc length given parametric equations. So we have two parametric equations here, um, and it creates this curve over the first 4 seconds. Notice that when x is 0, when t is 0, we input 0 in for t, and this becomes a 4. Likewise, when we input 0 in for t and for the y function, we get -2. So consequently, when time is 0, we're actually at this point down here at 4, -2. And then as time progresses, the particle moves. I believe at 1 second it's up here, and at 2 seconds it's on the side here. At 3 seconds it's down here, and at 4 seconds it's come up to this point. So we can actually find the length of this curve using our arc length formula. So our arc length formula that we talked about in Unit 8 starts with this concept. The integral means you're adding up an infinite number of really small things. So we're adding up an infinite number of Pythagorean theorem quantities, which give us the hypotenuse, right? So if we did this an infinite number of times with really small pieces, we'd actually get a bunch of tiny hypotenuses that add up to this full length of string. Okay, but we have functions in terms of t, so we need to get dt involved here. So we're going to change to dt by bringing dt in, but we can't just put a dt on there. We can only multiply by 1. So I'm going to put the square root of dt squared in the bottom there. But now I can bring it in, right? So I've got my radical, and since that has a square root, I can bring it inside. And so we actually get dx over dt squared plus dy over dt squared, and then on the outside is a dt. So that's nice and convenient. And now we want our limits to be values of t. So our start time is 0 and our end time is 4. And so what we would do from there is take our two expressions and put them in these places. So in for our dx over dt. So you're going to put one expression in there and the other expression in there, and then you'll use your graphing calculator to determine the arc length.